This video is about radical chemistry. Radicals can be broadly defined as any chemical species with an odd number of electrons. They are more reactive than regular anions because all elements want to have 2 electrons in each of their orbitals. Radicals are formed by homolytic cleavage, which is when a covalent bond splits apart, sharing 1 electron with each atom involved. This is not energetically favorable, so usually you require high amounts of energy for radicals to form. This is often shown as light or heat energy. The stability of carbon radicals follows the same trends as carbocations. The most stable will be something with lots of resonance, whilst the least stable will be something without any resonance and no other stabilizing factors. Resonance is shown the same way with radicals as with any charged system. Just show your arrows with single prongs as opposed to full prongs, as this depicts the movement of a single electron as opposed to the movement of 2 electrons. But back to the point. Just like carbocations, the reactions tend to want to form the most stable radical. So if you're deciding where to make the radical, make it where you would form the most stable radical.